Welcome to Part 2 of the Design and Technology Lab's CNC Router Guide. In this video, we will cover the recommended CAD workflow and file requirements to generate your 2D drawing and 3D model for CNC routing. This guide operates under the assumption that you have a basic understanding of CAD modeling and drawing. Rhinoceros is used at the Design and Technology Lab for the creation of machining files. However, the following information and principles are transferable to many other CAD softwares and should be taken into consideration. When creating your CAD file, you can think of the modeling space as a digital representation of the CNC router's physical bed. It's important to understand where the origin point is in both the modeling space and on the CNC router bed. The y-axis in your modeling space runs along the short side of the CNC router bed. The x-axis runs along the long side of the CNC router bed, and the z-axis runs vertically from the CNC router bed. Where the three axes meet is considered the origin point. It should be the 0, 0, 0 coordinate in your modeling space. Keep in mind when designing for CNC operations that a three-axis router is unable to perform undercuts. Rather, it is best used as a surfacer for your stock. The following information will demonstrate the proper format for your CNC files. If appropriate requirements are not met, the operating lab technician may decline your files from being processed. It is recommended that your model is created in Rhino 3D. However, you may import a model from another modeling software. If this is the case, you should take extra precautionary steps to fix any geometry errors that may occur during conversion. This may include unintentional open curves, non-manifold errors, overlapping geometry, and more. Depending on the software of your choice, you may need to convert text into vector outlines before import, otherwise your font will be lost in conversion. Before creating or importing your model, make sure your model units are set to inches. Your machining model or pieces should be no bigger than the CNC router's workspace. Within the same file, include both a 3D model of your design and a set of control geometries. This will help the operating lab technician to better understand your project. Start off by creating layers for your model, stock, and control geometries. Differentiating layers through color is recommended for ease of visual identification and clarity. On the model layer, import or model your 3D design at 1:1 scale. On the stock layer, accurately model your stock according to its dimensions and its actual measured thickness, not the labeled or assumed thickness. Orient the top edge of your stock to the origin point as shown here. Be sure to place all geometry within a 1/2 inch margin of your stock. This margin accommodates for the position of screws and other fasteners which may be required to secure your stock to the CNC bed. Subsequently, each operation should be isolated into their own sublayer under control geometries. Name each sublayer by identifying the operation and the desired depth as shown here. For 2D milling processes, operations include engraving, which runs along open or closed planar curves, pocketing, which removes a material within a closed planar curve, or profiling, which is used to cut out material along closed planar curves. For 3D milling processes, create a sublayer under control geometries named surface geometry. This layer should only contain one continuous surface, which represents your desired surfacing result. Unlike 2D milling, the depths of 3D milling do not need to be defined in layers. Rather, RhinoCam will use your surface geometry to define milling paths automatically. Typically, this involves at least one roughing pass and one finishing pass. Once your file is complete and all applicable requirements are met, save your file according to the Design and Technology Lab's naming convention as shown here. It is recommended that your file be saved in .3dm format. With your CAD file complete, you are now ready to move on to the next step, programming your CAM operations.